Looking at the Earth, the first thing you're likely to notice is all the water. Under the bright white clouds, the blue oceans cover over 70% of our planet. Even so, all this water is but a tiny fraction of the Earth's mass, and according to one leading theory, most of it wasn't even present when our planet first formed. The European Space Agency's Herschel Space Observatory has played a crucial role in our efforts to understand the origin of water on the Earth, in the solar system, and across the universe. Operating well beyond the obscuring water vapor in Earth's atmosphere, Herschel's infrared detectors had a perfect vantage point to look for the spectral fingerprints of this important molecule. Water molecules consist of two hydrogen atoms bound to a single atom of oxygen. Hydrogen has been around since the Big Bang, and oxygen formed in the nuclear furnaces of stars that died long ago. To better understand where and how these atoms come together to form water, Herschel searched for it throughout the cosmos. While water vapor was already known to be present in star-forming regions, Herschel was the first to find it in this pre-stellar core in the constellation of Taurus. This cold lump of gas and dust will someday become an incubator for future stars and planets. But it already is seeded with enough water to fill Earth's oceans millions of times over. This means water should be readily available when planets begin forming in the disks around young stars. While water in various states had already been found in planet-forming disks, Herschel was the first to find cold water vapor, pointing to the presence of larger, unseen reservoirs of ice at greater depths. Looking closer to home, Herschel scrutinized objects within our mature solar system to see how water is distributed here today. Scientists are particularly excited about identifying the source of our earthly oceans. Was the water already locked within the crust and released into the atmosphere through volcanism? Or was it deposited on the surface through bombardment of asteroids or comets? Cometary bombardment was more common long ago, but it still happens occasionally. In 1994, the world watched as comet Shoemaker-Levy 9 slammed into Jupiter. The dramatic visible blemishes faded within months, but 2 decades later, Herschel was able to find water vapor in Jupiter's atmosphere and connect almost all of it to that impact. Whether or not Earth's water was delivered by ancient cometary impacts hinges on the nature of cometary water. It turns out that not all water is created equal. Some of the hydrogen found in the water contains an extra neutron, making it a little heavier. If the oceans came from comets, then we would expect cometary water to have the same proportions of ordinary to heavy water. Before Herschel, a few long-period comets have been studied and were found to have too much heavy water to match our oceans, making comets a less likely source than asteroids. However, Herschel's examination of 2 short-period comets found a ratio that was a good match and reopened the debate. We are far from a clear answer though, since data from ESA's Rosetta mission to the short-period comet 67P again found a much larger proportion of heavy water. Clearly, there is still a lot of detective work to do on the origins of water on Earth. Herschel has observed water across the cosmos, ranging from bodies in the solar system through the Milky Way out to distant galaxies, but it has only scratched the surface of the proverbial iceberg. Its discoveries have laid the groundwork for future investigations that will build on its legacy for years to come.